I'm going to take this video to go over the S-shift Laplace transform equation. It's this guy right here. Typically, you just see it as that. You don't see it with where the Laplace of f of t is, but I put that there just to clarify some things. And I'm going to assume that you know the Laplace transform for t to the n, sine of at, and cosine of at. So I'm not going to work out where this comes from. I'm just going to show you how to use it. So let's start by doing, and I'm doing it specifically from an inverse Laplace transform perspective. So say I've got 1 over s squared, and I want to inverse Laplace this. Well, you should see that it takes this form, right? And I identify the n value by looking at that 2, right? So n is 2, which means that I get, sorry, n is not 2, n is 1, because I have a 2 here, and that if I add them here, I get the 2. So that inverse Laplace is to t, and the n factorial doesn't matter because this is t to the first power, so 1 factorial would give me that 1. I always like to identify the power of this t piece and then work backwards and figure this thing out. So let's do the Laplace transform of 1 over s minus 2 squared. So what I want you to see here is that the base expression that I have here is 1 over something squared, right? So it actually takes the same form as this one right here. But where instead of having an s, it's got an s minus 2 instead of an s. So this formula up here, I'll copy it, put it right here. If I look at that right there, then my f of s minus a for this one right here is equal to 1 over squared s minus 1. Sorry, s minus 2. So what I want you to see is that this a value here is 2. So a is equal to 2. That is this a right here is 2. So what that tells me is if I'm trying to inverse Laplace it, that this thing is going to have an e to the 2t times something, right? So if I remember inverse Laplace, it is moving it backwards, right? So maybe it's even better to write this value. That is this thing right here. So that's negative 2. So then I go back and I say, all right, so a is 2. So I'm going to put my 2 right there. But now I need to, multiply that by something right here. So I need to figure out what that f of t is. Well, if f of s minus 1 is equal to 1 over, or sorry, f of s minus 2 is equal to 1 over s minus 2 squared, then to figure out what f of s is equal to, I'm just going to get rid of the minus 2. That would be 1 over s squared. And notice, if I inverse Laplace this, I get f of t. And here I'm like inverse Laplacing the whole equation. F of s is 1 over s squared. So if I inverse Laplace that, I get f of t is 1, or sorry, it's not 1 over, but it's just t. That's the same one that we did earlier up here. So that is this piece right here. So I'm actually pretty much almost done right here. Let me zoom out a little bit so we can see everything. I started by looking at this thing and saying it's 1 over something squared, and I've got an s minus 2 instead of an s. So I worked this formula, f of s minus a. Well, a was 2. So what's that mean? When I go and do my inverse Laplace, then I need to get an e to the at. Well, a is 2. So I get e to the 2t times, I'll do it the other way around, times, all right, f of t. Well, f of t would be the Laplace of big, or the Laplace of f of t is big F of s, right? So that's what I said right here, right? So once we identify what f of s is without the minus 2, which is 1 over s squared, I inverse Laplace that and I get the t, and that becomes my f of t here. So I get e to the 2t times t. And we would probably write that as t e to the 2t because it just looks better like that. Let's do another one. So so that's my e to the at times f of t. Well, really that one. Okay, so let's do another one. So let's do 1 over s plus 4, but we're going to cube it this time. So let's look at that structure that we used up there. Come on, get out of here. All right, it was something over squared, right? So this is something over cubed, right? So when I'm looking at this, I'm going to say, all right, instead of an s, what do I have? I got an s plus 4 instead of an s. So a is equal to negative 4. Why is that? Because f of s minus a is equal to 1 over s plus 4 cubed. So what do I have? This is a double negative there. In order to get that plus 4, I got to have, this has to be a negative 4 right here, because that would give me a double negative, which will give me an s plus 4. So that means f of s minus 4, or plus 4. Maybe I should write it like this. S minus a negative 4 is equal to 1 over s plus 4 cubed, right? So what is f of s? If I get rid of the minus a negative 4, I get 1 over s cubed. Well, what would that inverse Laplace to? That would inverse Laplace to 1 over 2 all over, or sorry, I didn't do that right. 1/2 t squared. Why is that? Because the half balances out the 2 factorial that I would get. I always back the power up by 1 to go from the s's to the power. Remember, my a value is negative 4. So, sorry, this is my f of t. So I'm I'm writing that whole equation right there. And then if I copy, actually it's probably still paste. If I take those pieces right there, right? Remember, a is a negative 4, and f of t is equal to 1/2 t squared. So what is e to the at times f of t? Well, that's equal to e to the negative 4t times 1/2 t squared. So I write that as 1/2 t squared e to the negative 4t. And that is just taking these pieces and identifying them from this based on how this was originally given to me. So let's do another one. Let's do 24 over s plus 3 to the 5th. That's a 5, not an s. Maybe I'll make it try to 5. What does that inverse Laplace to? Well, first thing we want to do is look at 24 over something cubed. So it's got the shift on what would f of s be equal to. It's 24 over s to the 3rd. Sorry, s to the 4th. My bad. 5th. Why is that? Well, I don't know why I drew a 3 here. 5. Okay, so s to the 5th there. If I inverse Laplace this equation, I get f of t is equal to, all right, it's just t to the 4th. Why is that? Because I know it's a t to the fourth right here with that fifth power. Question is, what's the coefficient? Well, 4 factorial is 4 times 3 times 2 times 1, which is 4 times 6, which is 24. So that's actually set up perfectly. This would just inverse Laplace. If I were to do the Laplace transform of this, I would go straight to that. It's kind of like integrating where we work backwards. So that's my f of t. You should see the a value. A is -3. So if I look at this right here, right, and I take this piece as that, and I take a as -3, then I wind up getting that this guy, inverse Laplace is 2, e to the a is -3 times t times what's f of t, t to the fourth, which the better way to write it would be t to the fourth times e to the -3t, although either one really is totally fine. So hopefully it's starting to make some sense. So let's try another one. Let's do 48 over s minus 8 to the fifth. Well, I'm going to do it in sort of just a couple steps here. That inverse Laplace is 2 because I want you to see how to do it in just a couple steps. Okay, so what I'm going to do, I'm going to look at the shift part first. That's clearly an e to the 8t. Next thing I'm going to look at is the 48, or sorry, I'm not even going to look at the 48. I'm going to look at the 5, right? So the 5, what does that tell me? And I'm going to leave a gap there. So the 5 tells me it is t to the fourth, just like the previous one. And now the 48, I'm going to write in here, I'm going to take 48 and I'm going to divide it by the factorial for this over 4 factorial. Well, we know 4 factorial is 24, so this is 48 over 24, which gives me 2. So that means that I fill in a 2 right there. And then I'll rewrite it, 2e to the -8t times t to the fourth. And honestly, it doesn't matter which order you do these guys in. Either one is totally good. So let's do another one. Let's do 18 over s plus 10 squared plus 9. So I think you should recognize, all right, my a value for the exponential shift part is equal to -10. So it is e to the -10t times something. Now all I got to do is figure out that something. So I'm going to take this thing and just write it without the s plus 10. What's that give me? 18 over s squared plus 9. And then that, it's actually in a sine of at form. I just got to figure out the values of all these things. So I'm going to write it as over s squared plus, well, 9 is 3 squared. So I'm going to write my 3. And then I'm going to say, what do I need right here to get an 18? I need a 6. So what is that inverse Laplace to? It inverse Laplace is to 6. And then sine of a value is 3. And this is a different a from that a. So 3t. So what do I get? This goes in that box, which gives me e to the -10t times, with a 6 out front, sine of 3t. See if we can get one more in a minute. Let's do 72 over s minus 6 to the fourth. See if we can do it quickly. Inverse Laplace. All right, so it's clearly an e to the 6t times, fourth power here means t cubed, and then the question is, what do I put in there? Well, in here, I'm going to put 72 divided by 3 factorial. Well, that's equal to 7, and it's kind of like when we integrate, right? We always divide, right, when we're integrating. So I get 72 over, what's the 3 factorial? 6, and I think that's 12. So I get a 12 in here. So my answer for the inverse Laplace for this is equal to 6t times t cubed